Okay, welcome. My name is Dean Case. I'm the membership director for SAE SoCal, and welcome you here to our latest meeting. Part of the success of SAE SoCal over the last year, I'd say, is our great collaborations. And with that in mind, I'd like to introduce a few folks to talk about some of the things we've done here. Luis Morales, before you sit down, you want to come on up? We did an event last month at the SEMA Garage that attracted 425 students from 30 different universities. So if you are looking to hire engineering talent, we are the place to go. And thanks to our friends at the SEMA Garage, we've got this amazing venue. Luis?
Thanks, Dean. Hey, everybody. For those that don't know me, my name is Luis Morales, and I work for SEMA. Many of you know as the SEMA show that happens in November, all automotive aftermarket. But the other days outside of the SEMA show, I get a chance to work at one of our facilities known as the SEMA Garage. Two facilities, actually, one based out of California, the other one based out of Michigan. And my whole job is to essentially work with aftermarket companies and help them develop their products from start to finish. And I also get to oversee their vehicle technology side, which means that I get to look at what's on board of the new vehicles today and understand how that's going to integrate with aftermarket products in the future. But I've had the chance to work with Dean and the rest of the SoCal SAE board for multiple years now. On connecting students that come from an SAE background, whether that's Formula or Baja SAE programs, and the automotive industry, and how that opportunity can present itself as a career in the automotive aftermarket. So I come from a background of being part of Cal Poly Pomona's Formula SAE program. And while I was in school, we didn't have an event like this that connected us to the aftermarket industry. So very proud that we've done a really good job at nailing that program down and bringing in 300 to 400 students every year to our facility. So thanks, Dean, for giving me the opportunity to say hello. Thank you.
Thank you. Next, Jim Dvorak. We got Motor Press Guild here. Jim, tell people about Motor Press Guild.
Okay, thank you all for coming, and wanted to tell you a little bit about Motor Press Guild. We've been around since 1990 in Southern California. We started as the International Motor Press Association Western chapter, and then branched off in 1990. I've been a member since 1995, and I'd recommend everybody to be a member. Journalists, affiliates, PR professionals. If you're in the automotive industry, it's good to get connected with MPG. I have to thank MPG for connecting me with a lot of people that got me started in my career in automotive public relations. And it's a great place where you can meet people like Dean Case, KJ Jones, and Lana Chrisman. If there's 5 things that you need to do is also join SEMA, get connected with SEMA, but get to know Dean, Lana, and KJ, because they know everybody, and that's how you advance in the field. Just really want to thank Dean for his partnership with SAE and the great programs that he puts together. Thank you.
Is there anyone here, is this your first time to visit the Lions Museum for anybody? A few of you. This is an amazing facility, and it's hidden away. Lana, you want to say a few words about this and the fact that this space is available for rent for your corporate events? So.
Hi, everybody. I want to welcome to Lions. This foundation was created in 2019. It was a vision of Rick Lorenzen, our founder, and this was his private collection, many of these cars, about 150 of them. In 2019, he donated them to the foundation and started this great machine going for us. So it's been going on 5 years now. And it's all about, bringing youngsters into the industry, showing what a great career you could have in our industry, in the automotive industry, and in the trucking sector. So welcome here. I'm so glad to see a great audience tonight. Like Dean said, we are available for rentals, but it's all about education and giving back to the community. And I really appreciate everybody being here. Mike, Dale, Karl, I appreciate you. You are our first industry panel that we've had here. So thank you so much for supporting us. And I hope to have many, many more events like this. Thank you, guys.
Did we have anyone from DSF here? Come on up. One of the things, SAE is, we have a really great relation with all the local four-year schools, but we found some collaborations that we're trying to build for other aspects of the industry and the sport, including technician training. And I'm not sure how I got introduced to DSF, but You want to say a few words about DSF and what you're doing?
Hey, yeah, so we're DSF Works. We are a nonprofit, and we just help youth get in ages like 8 to 24, get into the shop, and we just teach them how to work on cars. So we have a shop in Signal Hill, and every Monday, 5 to 8, we open it up to the community, and we just feed you food. We make you food, like burgers, hot dogs. And yeah, we just work on cars together and learn a lot. So, during the rest of the week, Tuesday to Friday, we have 4 or 5 apprentices right now, or interns that's working, and we just hang out and just learn. That's what it's about. It's not a school. We don't have tests, but we just, just give back to the community and just go check out a shop or go do this or do a field trip. Just go out into the community and get connections to just better ourselves and just learn more. So it's all about learning. And it's super fun, yeah. There's one of my good apprentices, been with us for 1.5 years, and you've learned quite a bit, hey, Kenny? Yeah. So super cool. It's a nonprofit, so any support is much needed, right, to keep it going. But we had 45 people on Monday, and it's just really fun every Monday. Can't miss us. If you want to come to the shop, come talk to me after. It's an open garage, so it's really cool. Thank you.
I should ask, are there anybody out here with companies who are actively hiring right now for any positions? If so, raise your hand, because there's probably some people in the room who are looking for jobs. What are you looking to hire for?
I'm looking for fabricators.
Fabricators, okay.
Small shop, we do a lot of light mechanical, but mostly fabrication.
Okay, fantastic. So, we're trying to... Okay. And then last, did we get anybody from Vital Link here? Did our Vital Link rep? Thank you. SA, we've got the Formula SA and Baja SA competitions on the collegiate level. Vital Link is a group down in Orange County that is working with high school kids. And they've got a competition this Saturday at Saddleback College called their EV Challenge for high school students. So if you want to see, I see some students from Long Beach and a couple other schools here. If you want to recruit the next generation of Formula SA and Baja SA students, you might want to go down to Mission Viejo on Saturday. But so I'm going to turn it over to why you're all here, is to talk about nitrous and supercharging. And I know KJ Jones via the Motor Press Guild, but it's interesting, most of his career has been on the hot rod side, and I always worked for Japanese brands, so we never had anything that was really suitable for hot rod. We were always aiming for MotorTrend and some of the other titles. But KJ, when we decided, Alana suggested this topic in the speakers, I go, well, I need someone who knows a lot more about this than I do. And so KJ was the obvious person to come in and moderate. So KJ, I'll let you take it away and introduce your panelists.
Awesome. Thank you, Dean. Welcome, everyone. Thanks for being here. My name is KJ Jones. I'm a senior editor with Hot Rod Magazine. I've been with the Hot Rod Group for about 3 years now, but in the industry and working with magazines for closing in on 21 years at this point. So I've been around the block. I'm a performance nut, a hot rod guy, car guy, et cetera, et cetera. We have a great panel here to talk about power, to talk about performance, horsepower, by way of nitrous oxide and compressed air supercharging. So I want to ask a question first. How many people like horsepower? Raise your hand. Okay, it's pretty unanimous that we have horsepower people here. I want to introduce 3 horsepower gentlemen. Mr. Mike Thermos of Nitrous Supply. Mike, come on up. Dale Vaznaian of Compressed Air Superchargers. And Karl Staggemeier of Compressed Air Superchargers. What you're looking at is a collective many years in the performance industry. Starting with Mike, if you don't know, I consider Mike, he's like the godfather of nitrous oxide. Some people call him the godfather of pro-modified. Pro-modified is a drag racing category that souped up cars with power adders, superchargers, nitrous oxide turbochargers. And Mike was one of the ground zero people to use nitrous oxide. Bill Coleman with a Pro Mod car. Is that correct, Mike? Like Bill Coleman, and now you have your Scotty Cannons, et cetera, et cetera. But through the Pro Mod ranks, Mike was their guiding light, using nitrous oxide to go really fast in the quarter mile. He's got about 40 years collective experience in making power with nitrous, so that kind of says it all. He's been a mentor to many people. We were talking earlier, Steve Johnson, who has his own nitrous company now, but Jeff Prock, who is the brother of Jimmy Prock, who is John Force's, works with John Force Industries. He's been his mentor. In a way, he was my mentor. I used Nitrous Oxide Systems hardware for a long, long time when Mike was doing his thing, and didn't talk to him directly, but talked to a lot of people with his group and learned a lot about nitrous oxide. He's really made nitrous what it is. That's what a lot of people in our industry look at him as being the guy, so we're really glad to have him here. Dale is linked with Mike in a lot of ways. Dale was with Nitrous Oxide Systems for many, many years before he got into his compressed air supercharging company. Dale was the chief operating officer at NOS, Nitrous Oxide Systems, and he basically invented the fogger nozzle. If you look here on the table and you look at this intake manifold, both intake manifolds, they are what's called plumbed with little nozzles that go into the intake runners. That's called fogging, a fogger nitrous system, and those little nozzles there that inject nitrous and fuel were developed by that man there. Karl, I guess with all these people here, they're scientists of sorts, but I consider Karl like the mad scientist. He's a diabolical mind, because Karl was the chief technical officer. He was the chief engineer, basically, for 10 years in Nitrous Oxide Systems, and he was responsible, or the lead tech, for pretty much most of the nitrous oxide system product line. So he's the guy that probably sat in a small room by himself and thought of a lot of creative things to do to make horsepower using that nitrous oxide gas. He's a pressure specialist with gasoline and with pressurized pneumatics or air. So it makes sense that he's now working with the compressed air supercharging. And what we're going to do today is have these gentlemen talk about these two forms of power adding, and then we'll get into some questions that I have for them, and if there's time, we're going to have people in our audience ask some questions as well. So get ready for just a good discussion and to learn about nitrous oxide and compressed air supercharging. I would say respectfully, Mike, more so compressed air supercharging, because while it's not brand new, believe it or not, this was done back in 1971 by Mickey Thompson. But it's in a resurgence period, I guess you could say. At 2024 PRI show, we saw compressed air supercharging on a couple of cars that were displayed at PRI. And now via YouTube and social media, some of the people that are working with these systems are bringing it back out to the front. So it's kind of like a hot item right now, and it's really a good thing to talk about at this time. So gentlemen, if you'll take a seat and grab your mics. And basically, Mike, we're gonna give you the floor, okay? If you would, we're gonna give you the floor first, Mike, and if you just give a little bit of your history, but I'd like for you to talk about nitrous oxide and the principles and making power with nitrous. You know what, in a sense, you're about. I would guess that there are some people in here who probably don't know about nitrous oxide. One of the things that I'm on working at Hot Rod, don't assume that everybody just knows it. You know, as car guys, we kind of do that, and it's unfair to do that when there are people in an audience or reading your magazine and stuff who don't know. They're new to the hobby. So, Mike, if you would just give us a little bit of a background on nitrous and where you come from with it, and then we'll move on down the line to Dale and Karl.
Okay. Dale and I were formed a partnership back in 1978, I believe it was, and got into nitrous. I ran a little tune-up shop and did brakes and tune-up. Prior to that, I ran a funny car, and we were all learning in those days, in our early 20s, and it just got so expensive to try and run a car, we had to bail out. But Dale and I formed a partnership with the nitrous oxide, and we learned that was some 45 years ago. And we started a company that was called NOS, Nitrous Oxide Systems. And if you've ever seen the movie Fast and Furious, we were involved with that, with a lot of the import cars and all that crazy racing that they had. It was a lot of fun, though. Basically, nitrous oxide is two parts nitrogen and 1 part oxygen. Now, as we raced over our years, we found that the fuel is what makes the horsepower. Nitrous oxide does not make horsepower. It actually burns the fuel that makes horsepower. And so the early attempts with nitrous were not too good because people thought nitrous oxide was a fuel, and it really wasn't a fuel. So when you put it in the motor, the car ran really strong for about 100 feet, 200 feet, and then it smoked 3 or 4 pistons because it was just lean as hell. And our concept was to put fuel in and then figure out how to burn that fuel. And that's what the nitrous was all about. We brought nitrous in, and you had to be very careful because it was so easy to put more and more in. We learned over the years it didn't take much nitrous, and there was a limit you could put in. And we were fraught with all kinds of myths and things in those days. Nitrous blows up your motor. It does this. It does that. A lot of things were in the industry that didn't make sense, but guys were having problems with it. And I think Dale and myself, and then Karl came aboard and made Dale and I honest. And we started building kits, and they got very popular. If we take nitrous oxide and take it from the tank forward real quick, nitrous starts as a liquid in the bottle. It's about at 900 psi at ambient temperature. It is then pressurized up to the firewall area, and it will go through a solenoid, not a regulator, but a solenoid that allows the liquid nitrous to go into the plenum, into the engine. When it does that, and it comes out the nozzle, it comes out at minus 127 degrees, which that in itself just cools the intake charge to no end. And that's the first thing that happens. After it goes in the cylinder and oxidizes the extra fuel that you put in, you got to put in a little fuel with it. We put in fuel, then it burns that fuel. And horsepower is relative to how much fuel you burn per given amount of time. And we could burn more fuel in that same amount of time. And it started out with just a plate, simple, under the carburetor, and we could make 150, 175 horsepower quite easily. And as people tried to get more and more, we had to go to a fogger kit, somewhat like that went into each runner so that we can make sure each runner had equal amount or the proper amount of nitrous fuel combinations. And you could do that with jets. And it was pretty basic, pretty simple, really. It didn't take, wasn't anything epic. And it grew and grew. And we started going, we went to NHRA and ran a few of their races. We got nitrous put on a number of funny cars back in the early 80s. And they, Dom Perdome didn't run nitrous, but faked everybody out with nitrous. And he ran really fast, but we got the nitrous, it got banned from NHRA racing, which sent Dale and I over to IHRA, which was kind of a second string, and we started cultivating a use for nitrous there. And we came up with what is now called Pro Mod. And it was some fun years. They had 57 Chevys with big engines, and it was happening down south. And those southern boys, they don't know what 283 inches are. Everything is, nowadays it's over 900 cubic inch engines. They're huge. Pistons are like coffee cans. And they tend to really perform with nitrous oxide. There was a few things. You had to watch timing. It was so easy to make horsepower. The problem was a guy would just put a jet in there that's bigger, and he'd get into trouble. So you had to be very careful of how much nitrous you put in the engine. But as far as making horsepower, it was very easy to make horsepower with nitrous. Then just backing up here to about in 1999, Hawley Carburetor Company approached Dale and I and wanted to purchase the company. And we sold it, and we're supposed to retire. And I kind of went my way, and I didn't know anything else. And I started a little shop and filled nitrous bottles right here in Huntington Beach. And Dale started his program with this compressed air, and it's really fascinating to me of what that thing does. And I'm going to let him kind of go from there, because I'm pretty much kind of done with the nitrous. We can take questions later and talk about all the different things.
Okay. Yeah, we have some questions, and they're going to loop into a little bit more of the history of your companies and stuff. But you could pick it up and kind of give us an overview of yourself and Karl and how you guys came to develop or actually enhance something like this, because we won't call it development again. It's been around, but you made the clock tick a little better. Let's just put it that way.
You want to talk, Dale? Talk.
Yeah.
Yep.
Well, thank you. First, this place is really remarkable because there's probably 3 reasons I'm here. One of them's that drag strip on the other side of the wall there that you see, and it was my home away from home. I met Mike there, and he got me into the nitrous, and then we got Karl, and Karl got me into the supercharger. So that's, well, we could argue about that, but anyway, what happened was when we were running nitrous oxide in pro mod racing, they allowed blown alcohol cars to come in and compete, and nitrous is a normally aspirated situation where you got to rely on atmospheric conditions to load your motor, and we're racing superchargers with alcohol. And I thought, gee, if we could just compress the motor and get boost with nitrous oxide, we'd beat these guys. And we talked about it, and it was pretty complex. And when Holly Carburetors bought NOS out, I talked to Karl, and I said, gee, Karl, do you think we could make an engine work with compressing it with nitrous oxide? And well, we talked a little about it, and he said, well, let's try air. And so we slowly developed this thing into a working system. And he told me we could probably do it in 2 years and $25,000. It took 22 years and about 10 times that much. But so that's how we got started.
Very good. Very good. I guess we can. You guys didn't talk enough, okay? But we can go into some questions. I have some questions, and we're going to double back on some of the things that you said. Actually, I want to get into a little bit more of first Mike and Dale's history, but nitrous oxide. Let's think about this for a second. Nitrous oxide, what people probably know, and again, we can't assume everybody knows everything, but what people probably know in the performance space, nitrous oxide was used back in World War II. The German warplanes, Britain, US, we also used it to make the planes accelerate faster, to make the planes go faster. Because of the atmosphere and lack of air, you had to create an air condition, basically. So that was using nitrous oxide, am I right?
Correct, yeah.
Okay.
The air that we're breathing right now has about 21% oxygen in it. And when you bring nitrous to the party, it goes up to about 35% by weight. And that's quite a bit more than half, again, an atmosphere. So you get tremendous power out of that. And some of these supercharged cars, just so you know, I like to use a little bit of the theory, but John Force and these guys that are running these cars, I get a chance to talk to some of the crew guys. just an interest to me, but they're running 60 psi in the manifolds, and the engines are making 10,000, 11,000 horsepower, and the cylinder pressures are really high. And years ago, this was tried by Mickey Thompson and Krager and a few places, but they didn't have the technology that they have today. And I think that's where Dale and Karl have come in and really brought a lot of that forward. And it comes back just to what we learned in nitrous, and they've got a heck of a product. But I wanted to say one thing. When we talk about fuel makes power, I use an example of I don't know if you watched Fuel Funny Cars race, and they'll have a tremendous amount of fuel. These pumps are putting 80 gallons a minute through those motors in those cars. And when you think about that for a second, if you took the average mop bucket is about 2.5 gallons. And if you put 2 of those on the ground and you tried to fill those in 4 seconds, which those cars are running in 1,000 foot, you couldn't possibly put that much fuel in through that motor with a garden hose. That gives you some idea of the fuel consumption and how important it is in the equation of making this horsepower that they make today. And we learned that. We learned that fuel was the power, really the power source. There's another thing that Karl might bring up is the disassociation of nitrous. I don't want to get into a lot of the technical stuff, but that brings some horsepower also. Maybe he can explain that. He was the engineer that helped us tremendously in developing a lot of the nitrous technology that we have today. But what else you got?
I got more. I got more. I'm loaded. We think about nitrous oxide and, okay, German warplanes, but racing, the drag strip specifically. Who would think that nitrous oxide in a drag race application dates back to the 1950s? Anybody? You believe that? It's actually true. And a piece of nostalgia, I think Mike might know this. Mike, the first race car, if you will, that used nitrous oxide, and actually was compounded, supercharged and nitrous. Are you familiar with the name Gary Harms? 1958, supercharged Ford?
That was done with Bakersfield,
yes,
California. Sir. Yeah, I talked to those people a while back, and they had just put a hose up from the nitrous oxide and stuck it in the blower, and the car raced carless, and it put 2 cars on them coming off the line, and again, that's where they didn't have enough fuel to support the oxidizer, and the thing just leaned out.
Belts and pistons.
Yeah, melted pistons. Maybe Dale knows.
Yeah, it's interesting. I was at a trade show in Seattle, Washington, and with a nitrous bottle, like a table like this, and this guy, unlike most of the people, came in a suit and tie, and he kind of walked by and he came back, and he said, my dad was a scientist in World War II, and we're studying nitrous oxide, and we're going to, it got shelved because the jet engines had come out. And he said, I had a hot rod, and it had a flathead Ford engine, and he said, I wanted to soup it up, and I asked my dad about it, and he said, let's put nitrous oxide on it. And he was the first, has to be the first person back in, right after World War II, probably around 1950, that used nitrous oxide, and then other people saw it on his car and went from there.
Started the trend. That's pretty cool history, because you look at what nitrous supply is and what nitrous oxide is today, and to think back how crude it was, really. You know, just in a sense, throwing nitrous oxide at the engine directly, not metered in any sense or anything like that, and making power. But of course, it was detrimental to the engine over a short period. That's pretty much how it went. But Mike and Dale, you referenced Lions drag strip. And of course, next door, there's a great scale replica, a recreation of that drag strip. You guys, did you meet at Lions? Did you meet in high school? How'd you even come together?
Well,
You remember?
yeah, I had a tune-up shop and was doing tune-ups, and I raced the funny car, and it got so expensive to try and run that car, I couldn't keep up with the cost of it. And Dale would come by my shop, and we went to Harbor College together, and we took the auto shop, and I think we met there, got acquainted, and Dale would come down to my shop and use the rack and change his oil, and we got a friendship going. And he had a little flathead dragster that was a lot of fun. It was a really light car, and when our funny car would break, because it broke all the time, because that's just the way those things did, then I would go out with him to some of the races where they had a flathead race, and I would help him on the car, and we just helped each other racing. And finally, I had to give it up and kind of stick to the knitting and just be an average, I guess, call it mechanic. But always had this love for racing and performance. And it took me about 6 months to get it out of my system. It's like having a gambling habit or something. You have to have a race car. And I had settled down. I think I was about 35 years old, just gotten married. And I'd read Hot Rod magazine and all the books. And I read a story about a guy in Lomita or Torrance that built some nitrous kits, 10,000 RPM.
Ron Hammer.
Yeah, Ron Hamill. Mm-hmm. And I went over there. He wasn't that far away from me, so I went over there and talked to him and learned a little bit. And I actually bought a kit from him, and I brought it back and I showed it to Dale. And Dale's dad had a machine shop, small machine shop, and we decided that he could make those plates and put nozzles in them and do those sort of stuff, and my place would be like a sales headquarters. And so we just shook hands, and we needed money. We didn't have any money, so you remember that I said, well, how much money you came from Palos Verdes? I thought you had a lot of money, but so I asked Dale, did he have any money? So he said he could get $1,000, and I said, okay, I'll get $1,000. So we got $1,000, and we put it in the bank with 2 signatures on it. No contract, just shook hands and says, well, let's give her a shot. And we started going after it a little bit, and just from the seat of the pants. And we burned up a few things too. But we started the company, NOS. I had a friend that was a sign painter, and he drew that logo, NOS, that became pretty famous. Coca-Cola ended up buying that out. And there's an energy drink now with that. And then the Fast and the Furious came out. We had just sold it to Holly, and we had a pretty good run at it. And this thing is the next step, I think, in the future. This compressed air thing, it's amazing what it'll do. I mean, it's there's no drag on it, on the motor. There's not a belt to run. Some of these cars, like John Force's car, just to run the superchargers, take 1,000 horsepower to turn that thing. That thing is so tight as a compressor. This doesn't have any of that. The other thing is that that's very remarkable. When you compress something, you heat it. When you release it, there's a tremendous temperature drop. And I think you're seeing 0 temperatures in the plenum, in the manifold. And that in itself, and it's dry, ice-cold air. So the detonation is very nil, very soft. And there's a lot more they can do. They're running these things on somewhat milder boosts, but I don't know, Karl could probably tell you 20 pounds is like 30 pounds because it's so cold. So, but I'll let them
Yeah, we'll let actually Dale and Karl, we'll discuss compressed air supercharging now a little bit. We'll get back to I have some nitrous questions, but I want to talk about this because I'm very curious about it myself. I was not familiar with this until just recently, again, the PRI show, and I walked around there and saw Tina Pierce's truck. And here's a truck, drag race truck, a young lady owns and built, and I couldn't figure any of it out, and that frustrated me. It frustrated the juice out of me because I didn't understand what was happening. So dove into some information that I could find online and found out about these two gentlemen. And then looking back, I'm familiar with this car because you raced this car in the PSCA back in the day. Is that correct?
Yeah.
And I used to race in the PSCA, and I do remember seeing the car in the PSCA races. So I didn't know it was doing that, though. I didn't know that was going on. But anyway, with compressed air supercharging. Now, Karl, you're the diabolical one in this group here. What put this in your head, man? What brought this to your mind?
Well, first of all, it was his fault. They sold us in 99. I left in 98 and went off and spent the next 23, 24 years doing alternate fuel stuff. Compressed natural gas, liquid natural gas, propane, hydrogen stuff. So anyway, a couple of years after I left, Dale came to me with a question referencing the Mickey Thompson thing and asking if we could do something like that, which started a deep dive into the subject. And the reality is that technology has changed immensely since Mickey Thompson tried that or Garlitz tried it in the 60s or whatever. So although the idea or the concept has been around for a long time, the capability of doing it the way we have has only recently come online, and that is back when Thompson did it, they used steel bottles that could hold maybe 2,000 PSI, and now we have Type 3 aluminum carbon fiber overwrap cylinders. We go to 3,300, and then we have electronic controls where we're able to essentially take 3,300 PSI and regulate it down to whatever boost level. We want 8 PSI, so we have virtually a 400 to 1 turn down on pressure control, which is pretty phenomenal in a lot of respects. So anyway, there's been a lot of evolution in electronic controls and valving and whatnot. So if anybody references the old Mickey Thompson article, it looks like a Rube Goldberg contraption. And yet nowadays it's very clean and simple looking. However, there are an enormous number of nuances in this thing, and I refer to this now as the 23-year overnight sensation because you said, well, I just saw it at PRI, and it's like, well, the concept started in 2002. This car first ran in about 2016, and it has very slowly evolved, but now it's caught fire. And it really started with Mark Griffin, who's here with us tonight, runs a Top Sportsman car, and you may have seen it on NHRA's television show where the car ran 680 at Houston and runs 680 at Denver. So because he's carrying his own atmosphere, the car is impervious to ambient conditions. So anyway, he's been out there carrying the flag for about 5 years, and then he got the Pierces involved, who you saw Dave and Tina's car at PRI. That added fuel to the fire, and now there's been a couple of no prep guys that have grabbed hold of it, and they've got huge social media following. So like I said, it was a slow ember burning, and about the first of the year it started to catch fire, and in the last month it's just kind of exploded. So for something we weren't sure was ever going to go anywhere, about the time we're ready to say the heck with it, it just took off.
Well, it's a count your blessings scenario, and it's also a testament to the power of social media. And, with what I do with Hot Rod now and our digital side and our Instagram, et cetera, and the amount of contacts that we get by way of views and likes and people reading the website, and it's just amazing that is now the medium that channels information instantly, first and foremost, and just to such a wide audience. So that's where you get that type of return, and that's really, really good. I have another question here that I'm very curious about. One of the things that intrigued me initially was, how is the compressed air system, Mike alluded to nitrous and using solenoids, et cetera, to introduce nitrous oxide to an engine. What are the mechanics in doing this type of a deal?
Okay, well, again, conceptually, this is working, right? Conceptually, it's very simple. You have high-pressure tanks in the back. You run it through a single-stage mechanical regulator, which knocks it down to nominally 100, 150 psi, depending upon your application. Run it through a shutoff valve, which is somewhat analogous to a huge nitrous solenoid, though it's much more complex than that. And then a secondary regulator, which is really a Bosch drive-by-wire throttle, which we can have mapped as a function of engine RPM. So literally, as engine speed comes up, we open the butterfly up, and then we're also able to what we call dome load the regulator, so we can increase the outlet pressure of the big mechanical regulator if you want to make a lot more power. So as an example, the system on this car, if you just take off with it and let it flow, it'll make 650, 700 horsepower, but through this feedback loop, we can take it into the 12 or 1300 horsepower range. So back of the envelope, you can explain this stuff in 2 minutes. The nuances it takes to make this stuff work took years and a ton of Dale's money.
And essentially, Karl, when the system is activated, what you're doing is you're going to close off your ambient.
That's correct. There is no ambient. The engine, it's set up so it runs like a normally aspirated car until you go wide open throttle, and the system is armed. So if you think of it analogous to a nitrous system, for it to come on, you open the cylinders up, you arm the system, and then you go wide open throttle with it. That's how we have it set up on some of the more sophisticated cars. They've got timers and all sorts of other things going on. But once you go wide open with the system arm, there's a isolation or a big butterfly valve at the end of that inlet track. It slams shut, and the engine runs solely off the compressed air that's coming out of the back of the car. So as Mike touched on, when you're expanding air, it's the opposite of compressing it. There's a huge temperature drop. So coming out of the regulator, we've measured well, theoretically it's 240 below zero, but we've measured, 140, 180 out of that. We've measured 80 below coming out of the ejector. And the lowest inlet charge temperatures I've seen are right around zero, but some of that is even the fastest acting thermocouples you've got can't keep up with a huge temperature drop in it. But the net effect of all this is with the super low inlet charge temperatures, you can run a lot of boost with the same timing the engine wants normally aspirated, and fuel quality requirements become a very secondary concern. So like Mark's car is a big block Chevy that's running 33, 34 degrees of spark. And I think I don't know if you got C12 in it, but he's got some sort of it's not an exotic fuel. And the car just runs and runs and runs and runs.
So a big block with 34, that's pretty aggressive.
2,000 horsepower.
Yeah, that's pretty aggressive. That's awesome. That was one of the questions I had also regarding timing and tuning, basically. But let's go back to the engine, small block or big block. As far as hard parts, what's the basic makeup of a compressed supercharged engine? Are you still looking at like a dish type piston? Is there a cam profile that's specific to doing something like this?
There is, but none of this. I mean, it's really not my sandbox per se, but none of it is as critical as it is with any of the other stuff. I mean, we run it on 9-to-1 motors. I think Mark's is 14-to-1. Just because the threshold temperature, the inlet charge is so low, the tendency to have pre-ignition or detonation is mitigated enormously. And we have proven time and again you can make big mistakes with this and not hurt anything. I mean, when we were first running out at West Tech, we accidentally were at fairly high boost and went to about 16-to-1 air fuel. And Steve LeBrewer, however
Brule,
his
yeah.
name, and, they were
Nervous
convinced
Steve.
we melted it. And it's like they went out and looked, and it's like, no, the spark plug looked like we were just driving down the street.
Wow.
So it is very forgiving. It's amazingly forgiving.
So I would say that the forgivingness is a benefit over respectfully, nitrous turbocharging and traditional roots or centrifugal supercharging?
It's very easy on parts. I mean, I keep referencing Mark, but he ran that car, I think, for a year and a half without the motor coming out, only running the valves on a top sportsman car.
Wow, that's awesome. For people who don't know a lot about that, that is amazing, because you look at some of the people in sportsman drag racing and how many times an engine might come out for, servicing is one thing, but because something got hurt, because you got too aggressive with a tune-up, because you didn't have timing right. Really, timing and fuel are everything in a drag race engine, and if you miss on either one of those things, you're probably going to end up with melted aluminum in some respects. So if you can continue with that type of longevity from something like this, that's pretty amazing. I guess one of the important questions would be versus, say, the three traditional power adders, and this will be a traditional power adder at some point. But what would be the price for someone to want to do this? I mean, your development costs you a lot of money, and for someone who wants to get into doing something like this on a sportsman level, not professional or anything like that, is this something that is applicable for a drag race? I mean, we have the Pierces that are doing it and the kid that doesn't know prep and everything, but is this something that could, in a sense, replace at a hobby level or a sportsman level drag racer?
Possibly. At this point, it's kind of a top-down thing, if you will, because you go back, when we started on this, we thought if we made 800 horsepower with this thing, it was going to be awesome. Well, by the time we got around to doing something with it, you could buy that off the showroom. So the first customers we had, instead of 800 or 1,000, wanted 2,000. And so I was like, okay. And that caused some indigestion, but, we did get there with it. But, it's possible it's going to, over time, we'll scale back to a lower sportsman level. Right now, just because of the way the market has evolved, or I should say evolved, suddenly appeared, the hits right now are massive. Serious people running for big money, right? The no prep stuff. They're the top sportsmen or whatever who have a lot of money in their cars. So the systems we produced to date and released are all, I don't think they're as much as a blower system, but they're expensive. And you also have the ancillary equipment. You have to carry around a compressor and cylinders because the consumption rate is high enough. So there's initial investment in it, but the huge savings is on the back end, and that's something that people aren't, it takes a while to digest, because I go back to, if you can run the car all season and not pull the cylinder heads off and do this, how much is that worth to you?
Oh, that's where you're saving for sure. And that gas fill up, is that something you go to air gas and get your tank replaced, or how do you?
They carry scuba compressor. I mean, the setup again, like Mark has, I keep referencing him because he was our first and our biggest customer. He's got a scuba compressor in his trailer and 3 or 4 big cylinders. We call them a cascade, where they fill them, and he just transfills between rounds. So he produces his own high pressure air.
Wow. And the time to fill up those 2 tanks, what would that?
Several minutes. You can fill it in several minutes.
And this isn't a situation like with nitrous. In a sense, you're cooling a bottle to fill a bottle, and you're heating a bottle to use a bottle. You basically don't touch that bottle beyond just hooking up.
There's some heat of compression when you're filling them, but you do it slowly. You got enough time between rounds. You do it slowly enough. You don't end up heating them dramatically.
I understand, but to use it, you don't have to have any type of, so there's no real pressure dependence.
No,
Whereas,
it's just air in a gaseous form.
That's
it's
amazing.
not a two-phase like nitrous, where you've got it changing back in, a balance between liquid and gas.
Right. Mike, going back to nitrous real quick, what would you say from an entry level? We talked about this with the Mustangs a little bit earlier. For an entry-level person, someone who's just getting into nitrous oxide, what is safe horsepower for like a stock engine?
Well, we used to figure that we came up with about a 40% increase is very livable. Meaning if you had a 200 horsepower engine and you put 40% in it, you could give it 80 horsepower without any side effects, so to speak. And you can go more than that, but you start getting into detonation and various things you have to address. But just to bolt it on a car and get 150 horsepower is quite remarkable, and it's a cheap trick. I mean, the kits aren't that expensive. In our day, we had kits under $400, and you could bolt that on your car and go racing. That was one of the things that made nitrous very attractive. It was pretty simple to just put a plate on there, put some solenoids on it, and have a bottle. It was we called it a cheap trick, and we sold a lot of kits, Dale and I.
I'll touch on that because personally, cheap trick, yes, the first nitrous system I ever purchased, I paid $200 for because I bought a used system. So I paid $200 for it and put it on. And I'm curious, when all of you, the first time you used nitrous oxide and experienced it, the nitrous shot, just experienced getting kicked in the pants and the car just taking off, how old were you when that happened?
We were, I don't know, 35. It was somewhere right in there when we started. That's what got us into that direction is mid-70s. Yeah, mid-70s. And it gives you a tremendous bottom end. It's like you put another motor in the car. And then the car just, you could feel it. It wasn't something that, well, did that make some more horsepower? You know, you put a cam in your car and maybe it picks up on top end, but it kills some of the bottom end. And you're always kind of, well, yeah, I picked up a little top end, but what happened to the bottom end? I lost a little bit of that. Nitrous just slaps you in the back and throws you in the back seat, and away you go. And that was its fun side. And a lot of people got off on that. There was a lot of, it was easy to put on. It was very understood. You pull your carburetor off in those days and slide a plate under there. Took you a couple hours, and you could go racing and pick up 150, 200 horsepower. The guys are now, I was just talking to Proc today, in fact, and I was asking him the question because I don't know what they're running now, but he's in touch with a lot of the Pro Mod guys, and he tells me these guys are making up to 3,000 horsepower with nitrous now. They're making 1,000 horsepower with the nitrous the way they got these motors. But the motors, the thing about nitrous is it's still a normally aspirated motor. You don't have any kind of way of checking the nitrous into the plenum, into the motor. In other words, once you fill the plenum up with nitrous, it'll just spill out as standoff. It'll just come out the carburetor or the fuel injector. It won't keep going in the motor like a supercharger, where a supercharger actually packs the motor, and you can get 60 psi in the manifold. You can't get that with nitrous. It's really atmosphere. So the only way you can get more in is to build a bigger motor. And then it takes a bigger gulp of air, nitrous air. And Musi and some of these guys now, they're running these motors 998 inches, almost 1,000 cubic inches. These pistons are like coffee cans, and they buzz them. I mean, they run them up, 7,500 RPM. And they're very expensive motors, but it's the only way you can really take advantage of using more nitrous, because you just need more engine to put it in. And think about that. A 960-inch motor is like two 454 motors in the car when you think about it. And fill that up with nitrous. Dale and I have even talked about putting a little nitrous in one of these things.
Well, that's actually a question I had. Nitrous oxide working in conjunction with another power adder. I know that nitrous and superchargers somewhat, nitrous and turbochargers, enthusiasts, hot rodders use the nitrous to spool a turbo, put a spool jet in the turbo, and that's to get the turbo to spin faster, spool up faster for people who don't know that. But what are your thoughts about using nitrous with other power
That's
adders?
another frontier in itself. I mean, that's the thing. If you don't want it to spill out the carburetor, trap it in there and give it a second atmosphere or 2 atmospheres, and now you've got now you got things that are going to happen. Karl would probably tell you what might happen too. So we don't know what that experience would be. It could be a little too much power for the motor. But these guys nowadays are. It's a different tune-up today, and what they talk about is cylinder pressure. And these funny cars are running 10,000 PSI. And the way they burn the fuel, they'll burn the fuel all the way down the power stroke. And they've really got the science on that. The beauty about this compressed air system is you could run at Denver or you could run at Houston, and it's the same atmosphere. I mean, it doesn't know you're down or you're up at 6,000 feet. So it's got the same amount of air going in the motor. So you can throw your weather station away. You don't need to really tune for that altitude.
Work on the moon too.
On the moon?
Yeah.
On the moon.
You would.
Gentlemen, what would you collectively say is your future? I think that nitrous, turbo, supercharging, those are trends that have sustained. They've remained steady. As we noted, this is something that's just now coming on real hard. It's been there. It somewhat, fell off or whatever, or was forgotten about, let's just say, and now it's in the front and it's going really, really hard. What do you not necessarily hope is your future? What do you really think the future is for this type of power adder and improving on it or enhancing it or just expanding on it to who knows what?
Well, no matter what we make, somebody wants more. And the current limit for the what we call our dual system, it's essentially 2 ejector nozzles as opposed to 1 in this, is we've seen on the test bench somewhere between 3,500, maybe close to 4,000 CFM, and we typically can get about 80 horsepower for every 100 CFM. So realistically, the biggest system we have now is 2,700, but the reality is everything on there can be duplicated. So as nutty as it sounds, I'm pretty comfortable we can put together a system that will make at least 4,500 if someone is crazy enough to try to do it and wants to spend the money to do it.
The thing that I worry about is the racers are a racing breed. I mean, they sell their first young. And if this thing comes out and beats everybody, and there's one of these and 10 of them, they're going to vote this out. They're not going to want it. They're interested in winning. And that's some of the fear of it. But it's such a great system that I hope they can override that and let this come in and be part of...
Well, it did first show up in public 10 years ago, so it's not like instantly on the scene.
In 1982, we were running top fuel cars.
Yeah, we had...
they outlawed us. That was the best thing that happened because it must be good if they outlawed it. So.
That's usually how it works. But are you now pursuing or plan to pursue presenting this formally to NHRA Tech and trying to find a place for it?
It has run. Mark's cars run NHRA Top Sportsman at Denver and at Houston.
So Top Sportsman, but that's a category that like nitrous superchargers, et cetera. So it's an accepted supercharger in Top Sportsman. Mm-hmm. But in the revisiting the fuel classes, do you think there's a chance?
Again, right now, the big interest seems to be in the no prep, big money racing stuff. And so you really have to respond to what the marketplace is. And it's like we might want to say we want to be a part of the NHRA show, but if the customers are over here and the money is over here, that's where we're going to go. We're not going to force it.
Absolutely. That's what I had to cover, and thank you, gentlemen, for covering that. I'd like to open up to the floor. If there's anyone in the audience that has questions for these gentlemen, we can take some questions in hopefully they have answers.
Yeah, I had a question about using regular air versus like pure air. There was a conversation earlier, we were saying that it had like maybe 20-35% oxygen, at least in normal air. But it seems like with this system you can run, in some cases, pure oxygen rather than just using a compressor.
No.
No.
I mean, and there's a very good reason for that. And when we, probably 10, 15 years ago when we started working with this, I started thinking, well, what about juiced air, nitrox, which is, like 30% oxygen or whatever. I think they even run richer oxygen mixtures than that in some diving applications. So that was back, and I did some adiabatic flame temperature calculations, and you get like, oh, no. There's a reason an oxyacetylene torch gets real hot, and no. You go molten aluminum really quick. And one of the characteristics of this is, like when he was asking, what about multiple power adders? My question is why? And the reason being, if you've got a turbocharger or supercharger or whatever, you got mechanical limitations on how fast you can spin it, and you run to surge limits or whatever else. And also you're creating an immense amount of heat in it. This thing, I mean, to this system, an engine is nothing but a variable orifice, and it's a total loss system. So it's not much of a stretch to say it'll flow the same amount of air on this as it will on an engine half this size, because the boost level is going to come up. Because, I mean, we could go down a rabbit trail talking about choke flow and whatever, but the short story is once you have a certain critical pressure drop across the system, it doesn't care what's going on downstream. So it doesn't care if the engine's running on a giant engine running on 10 psi or a small one running on 80. It'll force the same amount of air into it. So it's...
Got it.
It seems like you're relatively insensitive to spark advance because they're so cold. Are you able to benefit from lower octane fuels from the flame speed?
I'm guessing so. We never got deeply into that. Again, I'll reference like the top sportsman car where he's running 100. What's the octane rating you're running?
112.
112.
We ride at C23 all the way down to 104, and it's really no difference.
So yeah, it is insensitive to a degree. Have we ever delved deeply into it? No. I mean, our focus was on trying to make the mechanical stuff work, and so we've never been off into any sort of combustion research like we did way back with nitrous stuff in the 90s when it was a going business and we were trying to do a lot more, if you will, intensive IC engine work, as opposed to right now. We're just trying to make this stuff work, get it in the hands of racers, and they're going to go off and do whatever they're going to do, but just try to get them decent hardware to work with.
How about compression ignition? You guys play with that yet?
No.
I was just curious, how much compressed air do you need to do whatever? I mean, depending, I guess, for a race or one run down the track.
Again, well, how much power you want to make. As an example, this car carries 150, about 320 standard cubic feet in the back in those two cylinders. And for a high 8-second run, it'll use about a little over 1.25 of them. So in the faster cars, he's carrying, I don't know, 460 standard cubic feet or something, and a lot more air.
How fast have you gone in your car back there? What's the quickest you've gone? You've run 6s, haven't you, Mark?
Yes, we run 670s at 210, 8th mile 430s at 170.
Same ball game.
Yeah, so with the compressed air system, instead of, I guess, having a temperature increase with the air from superchargers or turbochargers or something like that, you'd have a temperature decrease, which means it seems like with the same amount of PSI, you have more air going into the system. So would you jet your carburetor?
Yes, you do. I mean, this typical engine at 8 pounds of boost, which is a little over half an atmosphere, will double the power output. And literally for every 8 pounds, you can another 100% of baseline increase because of the density.
I know some of the cars, the other cars are running EFI, and this one's a carburetor deal still, so it kind of answers one of the earlier questions I had was whether or not you could do a blow-through, which is obviously kind of like this case, assuming that you got enough fuel. But there's a computer that controls your valves and whatnot. What inputs from the vehicle does that need to run? Does it need to
This is set up off of RPM. Literally, we've got the butterfly angles, a function RPM controlled, so essentially you can carry constant boost across it. And you can do modified curves. And then the more exotic, faster cars, they're doing all sorts of secondary controls to traction and limited stuff and whatever. The architecture on this car is pretty simple. This was what we started out with.
Have you spoken with some of the aftermarket EFI companies to try to find partnerships in making their systems compliant and able to, in a sense, work this?
Well, yeah, the cars are running with Holley system and also MP3 Pro. MS3 Pro. So yeah.
Pretty much anything, drive-by-wire.
So yeah, most of them have, I should say most of them, these guys have enough control outputs and are able with H-bridge drivers to run drive-by-wire. Anyway, it's not really an issue. And going back to, way back when we started, there were a lot of carburetors around, right? So that's how we went with this thing, and we ended up working with Carb Solutions Unlimited. Kevin, I can't remember his name, out in the Upland area.
They're the blow-through guys.
He's a blow-through guy, but he had to do this very differently than he normally does because of the air density issues. He had to run way more fuel per pound of boost with this thing, just because that's what our system does. So, yeah, you're not going to yank a blow-through from just anybody and throw on. You're going to have lean issues.
Understand.
Did.
Any other questions, Eric?
The computer that you have in this, I understand, I think one of the other no-prep cars, Ryan, is in the process of using the Holley or whatnot to control the system without your computer. Is that a possibility? I mean,
yeah, you can do that. In fact, we did it in 2018, but it can be done, but you got to know what you're doing. And so when we first came out with this, we were trying to figure out how do we create something that is generic enough that when we get it in the hands of a customer, we don't have to have someone operating at this level to not screw things up. And so the control system that Ryan has got in his car, yeah, you can do it without the butterfly valve. And again, we've done that in this car, but it's very application specific. You got to tailor it to what you're doing in terms of the engine speed range you're working with. Anyway, it's a doable deal, but it requires a fair amount of aptitude to know what you're doing. So there will be other people doing that. I mean, and then there is Randy Westmoreland, if you're familiar with it. Now, he's using a double EPR system on his car, and it's an approach much more similar to this, only, again, another level of sophistication because he's running two of these things. So you can take the basic hardware and use it differently, but again, it depends on how good you are and what you're doing, how far off in the weeds you can go with the thing. Does that answer your question?
Yes, sir.
I know your guys' background is mostly like drag racing, so straight line going down. I know some of us here like do like endurance racing. Is there any kind of any idea of how to make this a endurance racing solution? Obviously, a supercharger for charges is working on the motor, which is using like a central loss. We have to compress the tank. Is there any way other than just putting a bigger tank in the car?
No, I mean, really, it's only applicable to what we're drag racing. You can't, everyone, I shouldn't say everyone, there's numerous questions. Well, can I get a compressor on board and regenerate? And it's like, theoretically, yes. Practically, no. I mean, it takes a 5 horsepower scuba compressor, I don't know, 30, 45 minutes to fill these cylinders. So that's 4 horsepower running flat out for that long to charge these. So there's no way you're going to have an onboard compressor that can react fast enough.
Along that same line, is there any possibility of looking at the land speed? Which technically you don't have to run the whole 2 minutes on it, but the last mile or 5 miles or whatnot, you can.
Yes and no. And I would say no, and the reason being temperature limitations. So as we talked about, the air charge, no matter how much air you're carrying in this thing, as you deplete it, first of all, you've got this high pressure throttling, so the air gets super cold doing that. But the second thing is, you're depleting the cylinders. Essentially, you got something that's called nearly adiabatic expansion, so the temperature in the cylinders is dropping radically. And you've got a large thermal mass in the system. So as it runs, there's video out there, like on Ryan's car, of watching the ejector nozzles freeze up during the run. So that gives you an idea that at that point, it sucked the heat out of the aluminum. It's cold enough to create frost, so you're below freezing. But it's kind of a roundabout answer. But what it comes down to is virtually all automotive stuff is rated for minus 40 degrees below zero. That's like a low temperature threshold. And we're below that. And super critical to these things is there's only one brand of high pressure hose I know of in the world that's acceptable for usage on this, made by a company called Kongsberg. And they'll rate their stuff down to minus 75 degrees Fahrenheit. But so all that feeds into the longer you run this stuff, the colder everything gets. And I'm sorry, this is a long-winded answer, but each bit and piece in this thing has a low temperature limit. Like our shutoff valve uses silicone diaphragms in it. They're good to minus 70 below. Below that, the elastomeric goes through something called glass transition, and it goes rigid. And it turns into a rock. So you get it that cold, you can't shut it. So even though theoretically you might build some monster with enough cylinders in it and capacity to run for an extended period, I mean, we've kind of put a maximum limit of maybe 15 seconds duration on. So yeah, the last mile at Bonneville or something, you could, but you're not going to run this stuff for an extended period, because not only can you not carry enough, you start running into secondary concerns.
Just like the limitations back in the day as far as Mickey and Craig were running the system, there were limitations back then. Things advance over time, and at this point in time, that's the limitation. But when we're looking to go.
Could you start really aspirated after, let's say, the first mile?
You can, I mean, it's a duration thing. Even though, as you know, that car was a nemesis, because how long ago was that? 80. Anyway, back when I was at General Motors, we did a Firebird with a Lingenfelder motor. We ran 290 something with it, and we actually went over 300 unregistered and flew the car through the air and burned the car and all this stuff. But anyway, yeah, Bonneville is still an acceleration contest, right? Even at the end, you're still gaining. You're gaining very little, but depending on where you stage it during, anyway, early on, but it comes back to how long can you run it. Again, we put 15 seconds on it. That's an arbitrary number, but you're not going to run forever on it.
Any other questions? Well, gentlemen, thank you very much for your time and your expertise. It's been good. It's been really good. Very, very, very informative, and hopefully people in our audience have gotten something out of this. Hope you enjoyed it.
Thank you, KJ. Thank you, Mike, Dale, Karl. Small world. It turns out that Mike's dad and my dad worked together at the fire department 40 years ago. So this is a small community. Where is our Vital Link rep, Dennis? You want to come up? He was stuck in traffic, so I'd like him to say a couple words about his event on Saturday at Saddleback College.
Hi everybody, my name is Dennis. I asked you, we run a electric vehicle competition across teams from LA and Orange County and down in San Diego. It's high school students building carts about half the size of that. So if you guys have some volunteer flyers, we would love to have you guys come out and really give your expertise, advice to some of the young students who are inspiring to be sitting up here someday. So if you guys do have some time, it's this Saturday. It's great. Performa, John Patterson, Kia, Hyundai, sits at Saddleback College. The SAV team from Cal Baptist is joining us. So if you guys would like, I have some flyers that I'm having in the back. We'd love to have you guys come volunteer, show these kids, you know, they're the future, right? So love to have you guys come out. And on top of that, it's all sponsored by Wahoo's. So if you guys like fish tacos, burritos, free food.
So I say for anybody who says kids aren't interested in cars, you're hanging out with the wrong kids. So we've got, you know, Formula and Baja SA students and these high school kids, the young adults at DSF. We got a lot of great things, and please, we'll send you out an email. TJ Keon is our video guy. All of these things are archived on the SAE SoCal YouTube channel. Take a look. We have over 40 videos there on a wide variety of subjects, and you know, it's amazing, this venue here. And if you haven't been here before, talk to the docents. These are not just people who like cars. Half of them worked on these cars at Lions. So you're hearing firsthand stories. So it's an amazing collection, and we just value this entire extended community. So thank you for coming. Thank you, TJ, Mike, Dale, Karl, everyone, and stay tuned for future events. Thank you.